Okay, back again. This morning, looking at Disagreeable Ascii from Codewars.com. There's the name, there's the difficulty, there's the site. Right. And we are doing it in Python on this one. Good old Python. Well worn, but well worth it. I'm experimenting with a larger type today, just to see how this goes. Into the instructions. You would like to get the weight of a name by getting the sum of the ASCII values. However, you believe that capital letters should be worth more than mere lowercase letters. Spaces, numbers, or any other character are worth 0. So what the heck does that mean? Let's drill down a little further here. This is one where you're going to be able to tell what's going on by the kind of the examples. So it says normally in ASCII, A has a value of 97, lowercase a. Uppercase A has a value of 65, space 32, 0, 48. To find who has the weightier name, you're going to switch all the values so. Uppercase A is going to be 97, lowercase a 65, and both of the non-letter characters are going to be 0. And it says that up here. Spaces, numbers, and any other characters are worth 0. So there's a little conversion here going on where your lowercase and uppercase letters are swapping values. Lowercase a is typically 97, and then lowercase a here is 65. So the uppercases and lowercases are switching values in this exercise. Really, you're going to be taking in a string and you're going to be swapping uppercase ASCII values for lowercase ASCII values, lowercase ASCII values for uppercase ASCII values, and ignoring anything else. That's really the whole thing. So some of you may be wondering, what the hell is an ASCII value? Well, internally, your system, of course, speaks numbers. You know, binary, hexadecimal, other numbers. Internally, computers process numbers. Text internally in a computer is represented as numbers. And I guess long story short, there is a chart out there called the ASCII table, and I'm showing it right here. And let me see if I can make it a little larger, if it actually works. Yeah, okay. So it can be seen. So you got this chart here, and let's move over to, let's focus over here on the right side, like here. For each character on your system, or I guess you could say on your keyboard, each representable character, there are corresponding numerical codes in several numbering systems. We're focusing on decimal. So on the ASCII chart, an A, lowercase a, is represented internally as a decimal 97. And if you go over here to the right, the uppercase A is represented as a 65 internally in decimal. So that's the conversion. And in this exercise, we have to swap the values where the uppercase A is actually going to be 97 and the lowercase a is going to be 65. And, you know, really for each uppercase becomes lowercase, each lowercase becomes uppercase. We're almost really swapping case in terms of number. And so that's kind of the beginning of it. The end of it is that we need to get a sum of all these values as we do the conversions. So there's a little gist of what's going on here. So let me move this stuff out so we can get it going. So going to be given a string and convert really ASCII values and swap them really, get a sum and then return it. Very good summation, right? Absolutely. Let's get in here. So I'm going to create a variable to hold the total weight, or really this is going to be the sum of the ASCII values. And I'm going to loop through said string, so to speak. And then for each one, if it's uppercase, I am going to get the lowercase ASCII value. In Python, to convert a character to its ASCII decimal equivalent, you're going to use the ORD function. And yeah, I'm going to use that. And when I use that, I'm going to take the decimal value and add it to my total weight. So it's going to look like this. Here it is, ORD, and I'm going to put the element that I am converting to ASCII, and then I've also got to make it lower, because if it was uppercase, or and actually this is wrong. Let me change this. I didn't realize this. This needs to be is upper, because the is upper function checks for is it uppercase. Because I need to see if it is uppercase, and if it is, I'm going to do the lowercase conversion. So if this element is uppercase, I am going to lowercase it and get its ASCII decimal equivalent. Got it? Got it? Good. Let's continue. So you got to do the same thing on the other side. If it's not uppercase, it's lowercase, so I don't really need to do a check for that. Because if it ain't upper, it's lower, or yeah, whatever. Don't need to explain that one to death. If it's lower, convert to upper, get the ASCII, keep it moving. And this is the whole thing, because any non-letter character is going to be a 0, for which there is no action to be taken, because adding 0 to a total doesn't get you anywhere. So forget it. Screw it. All right. Return total weight. Yeah, that's going to be the sum. And let's check it out. Alrighty, did not work. What do we got here? Range, length of name. I'm seeing the issue here is that I have to add a check for being a letter, because we need to ignore all non-letters. So I need to add a test case for if it's alphabetic. Is alpha. Let's go, let's go, let's go. And gotta select the right stuff. Yeah, so if it is a letter and, well, yeah, uppercase or lowercase, you go. If it's not a letter, you don't do anything. The thing is that the else was catching non-letters and adding, thus leading to a larger total. All of them are larger. So let's run this one. Those pass. Whoops. Oh. Well, yeah, it passes. Kind of skipped a step there, but let me go back here. I think. I'm locked out. I do want to show you guys it again, just to make sure you got it. All right, well, there is the total summation. There is the code. Check it out, screenshot it, study it, and that is it. So this is the winning formula. And that'll be it for this one. So I'll talk to you guys later, or you'll see a video with me talking to someone later. And that is it. I am out.